Let's do the next question. Find the step response of the LTI system defined by the difference equation y of n plus y of n minus 1 minus 2 y of n minus 2 is equal to x of n minus 1 plus 2x of n minus 2. Okay, due to the initial conditions are given by y of minus 1 is equal to 0.5 and y of minus 2 is equal to 0.25. Okay, so here they said find the step response. Okay, step response means output of the system or response of the system when the input is a step function, right? So here the input x of n is a step function. Step function means u of n. Okay, so let's do this question. Given y of n plus y of n minus 1 minus 2y of n minus 2 is equal to x of n minus 1 plus 2x of n minus 2. Okay, now I'm going to apply Z transform to the above equation. Okay, so applying Z transform to the above equation, then the Z transform of y of n is y of z plus the Z transform of y of n minus 1 is z raised to minus 1 y of z plus y of minus 1 minus 2 into the Z transform of y of n minus 2 is z raised to minus 2 y of z plus z raised to minus 1 y of minus 1 plus y of minus 2 is equal to the Z transform of x of n minus 1 is z raised to minus 1 x of z plus x of minus 1 plus 2 into the Z transform of x of n minus 2 is z raised to minus 2 x of z plus z raised to minus 1 x of minus 1 plus x of minus 2. Okay, x of minus 2. So now let me substitute the value of the initial conditions, that is y of minus 1 is equal to 0.5, y of minus 2 is equal to 0.25, then no values given for x of minus 1 and x of minus 2, so all these values are 0. Alright, so that is substituting y of minus 1 is equal to 0.5 comma y of minus 2 is equal to 0.25 comma then x of minus 1 is equal to x of minus 2 is equal to 0. Okay, so you will get over here as y of z plus, this will become z raised to minus 1 y of z plus y of minus 1 is 0.5 minus 2 into z raised to minus 2 y of z plus y of minus 1 is 0.5, so it is 0.5 z raised to minus 1 plus, and y of minus 2 is 0.25 plus 0.25, okay, is equal to, here it is x of minus 1 is 0, so it will become z raised to minus 1 x of z plus 2 into z raised to minus 2 x of z, because x of minus 1 and x of minus 2 are both equal to 0. Okay, so now I will separate each of these terms, making y of the terms with y of z separate and the terms of without y of z separate, right? So that means this will become y of z plus z raised to minus 1 y of z minus 2 z raised to minus 2 y of z, okay, plus, now the remaining terms are plus 0.5, and here 2 into minus 0.5 is minus 1, right? So it becomes minus z raised to minus 1, and then and this will become minus 0.5 minus 0.5, right? So I have expanded all these terms, is equal to this. I can take x of z common, right? X of z common, this will become z raised to minus 1 plus 2 z raised to minus 2, okay. This 0.5 and minus 0.5 will get cancelled, okay, and I can take this z inverse to this side, and I can take y of z common. This will become y of z into 1 plus z raised to minus 1 minus 2 z raised to minus 2, okay, and this will become is equal to z raised to minus 1 plus x of z into z raised to minus 1 plus 2 z raised to minus 2, okay. So you will get this answer. So now I will bring this one over here. So therefore y of z is equal to z raised to minus 1 by 1 plus z raised to minus 1 minus 2 z raised to minus 2 plus, and this will become x of z into z raised to minus 1 plus 2 z raised to minus 2 by, this is 1 plus z raised to minus 1 minus 2 z raised to minus 2, okay. So you got this, right? So as usual, this is called as the natural response, right, or free response, and this is the forced response, right? This is called as a natural response because this response is only due to the initial conditions, right? When you look at all these steps, you can see that this term is created only because of the initial conditions, right? That is why this term has been created, right? So this term has been created, and this is due to this is called as the forced response, that is response due to the input, okay. So now here this is the response of the system. The question they have asked you, this is the response, and the question they have asked you is to find the step response. Step response means response of the system or output of the system when the input is a step function. Input is a step function means x of n is equal to u of n, that is the step function. Or in other words, here x of n is equal to u of n, right? X of n is equal to u of n. Therefore, x of z is equal to z by z minus 1, right? 1 by 1 minus z inverse, or z by z minus 1. So substitute this x of z in the given equation. So in that case, you will get y of z as y of z is equal to z raised to minus 1 by 1 plus z raised to minus 1 plus 2 z raised to minus 2 plus this x of z will become z by z minus 1 into z raised to minus 1 plus 2 z raised to minus 2 by, this will become 1 plus z raised to minus 1 minus 2 z raised to minus 2, okay. Okay, so here I want to remove all this negative powers of z, right? Negative powers of z. So if I want to remove the negative powers of z, I will multiply both the numerator and the denominator with z square. Likewise over here also, right? You can see there are negative powers of z. So I will multiply both the numerator and the denominator with z square, okay? So that I can remove all these negative powers of z. So if I multiply z square over here, z raised to 2 into z raised to minus 1 is z by, this will become z square plus z plus 2 plus z by z minus 1 into, and here it will become z square, right? Multiply z square, so it will become z square into z raised to, so z plus 2 by z square plus z plus 2. Okay, so you will get this value, right? So you will get this value. Okay, so you got this value. So now I think it is minus, it's not plus, it's minus over here, minus. It's minus over here, minus. Here also it is minus, right? Minus. Okay, so now I'm going to factorize this. So now I can write this as y of z is equal to y1 of z plus y2 of z. Okay, y1 of z plus y2 of z. Okay, so now this is y1 of z, this is y2 of z. So I will find the inverse of both these functions and then add together. Like that I will find the value of y of n. Okay, so here y1 of z is equal to z by z square plus z minus 2. So which are the two numbers? How can we factorize this? Find two numbers in which if we add them you will get 1, and on multiplying them you will get minus 2. Which number is that? That will be 2 and minus 1, right? Because 2 minus 1 is 1 and 2 into minus 1 is minus 2. In other words, this can be factorized by z by z plus 2 and z minus 1, right? Z plus 2 and z minus 1. Okay, in other words, now I am going to apply partial fraction to this. To apply partial fraction I have to preserve this z, right? I have to preserve this z, or I have to put one the z at the denominator. So this will become y1 of z by z is equal to 1 by z square plus z minus 2. Okay, and this can be factorized as, or this can be factorized as 1 by z plus 2 into z minus 1. This can be written as a by z plus 2 plus b by z minus 1. Okay, so here the a is z plus 2, right? So remove z plus 2 from here, write the remaining expression 1 by z minus 1. Okay, and substitute the value of z as z is equal to, here z plus 2 is equal to 0, so z is equal to minus 2. So substitute the value of z as minus 2. You will get over here as 1 by minus 2 minus 1, which is equal to minus 1 by 3. So the value of a is minus 1 by 3, and the value of b is equal to, the denominator of b is z minus 1. Remove z minus 1 from here, write the remaining expression 1 by z plus 2, and then substitute the value of z as z is equal to 1, and you will get 1 by 1 plus 2, which is equal to 1 by 3. Therefore, the value of a is minus 1 by 3 and the value of b is 1 by 3. So, therefore, y1 of z by z is equal to minus 1 by 3 into 1 by z plus 2 plus, and the value of b is 1 by 3, 1 by z minus 1. Okay. Now, I am going to put this z back to where it belongs. So this will become minus 1 by 3 into z by z plus 2 plus 1 by 3 into z by z minus 1. Okay. So this is y1 of z. In other words, y1 of n, let me write it in the next equation. My daughter made the scribbling over here. So in that case, y1 of n, right? y1 of n is nothing but minus 1 by 3 z inverse of z by z plus 2, right? plus 1 by 3 z inverse of z by z minus 1. Okay, or in other words, y1 of n is equal to minus 1 by 3, and the z inverse of z by z plus 2 is minus 2 raised to n u of n, right? Plus 1 by 3, the z inverse of z by z minus 1 is 1 raised to n, right? 1 raised to n u of n, right? So 1 raised to n is 1 itself, right? So you will get over here as minus 1 by 3 minus 2 raised to n u of n plus 1 by 3 u of n. This is y1 of n. Now I am going to find